All right, guys, welcome back. Just so that I know that everybody's back with me, if you could just unmute your video for a second so I know I've got everybody back with me. I don't want to start before I see everybody. Don't worry, you all look beautiful. I also see everybody like playing with their hair.
That would be the migraine.
Oh, all right. So Tom has a migraine. Wasn't playing with his hair. That's all right. All right, Gabrielle, are you there? Well, for everyone, we're just waiting for Gabrielle before we start. There is another student Excel book that I uploaded to Lab 14. So you're going to want to find that one. I'm going to start sharing my screen so that you can sort of see what I'm doing. So let's see. Under Lab 14 on Blackboard, there is an Experiment 14 data sheet that's here. So you're going to want to download this one. And I encourage you, after you download it and open it up, go ahead and save it. Now again, rather than saying student, put your last name in there so that when these all get submitted, we're all good to go. Now, really good news about stuff here, guys. We're pretty much finishing up all of your post-lab stuff for next week. There's just a couple of questions on the end of Lab 13 and the end of Lab 14 that you'll need to answer. Most of the work we're actually doing right now. So if you go ahead and open up that sheet, it should have two sets of experimental data, which are the same data that's listed on, I think it's the fourth page here of Experiment 14. But rather than having you guys have to take the time to type that in, and there's a lot of risk that somebody types something in wrong and they're not going to get the right answer, I just typed in all of this data already for you. So I'm going to look at everybody here. You still mostly have your videos on. If you don't, just put your video on just for a second and let me see. Give me a thumbs up if you have been able to open that document and you're good to go. I don't want to move on until I see thumbs up from everybody. All right. Tom, I don't know if I saw some thumbs up from you.
My internet speed's being a bit slow, so downloading the new it's taking a while to download the thing.
Okay. All right. Well, but you're close. All right.
Yeah, it's almost done.
So I'm going to play, I've got a video that sort of accompanies this one as well. I think this one's going to go fairly quickly. I think we should be able to be done by just about 4:30. So we'll be out a little bit early today. But let me go over and I'm going to start sort of showing this video that talks us through the calculations that we're going to do here. Oh, you know what? I think I need to make sure when I share my screen, I share sound. All right. Experiment 14 is another experiment on kinetics and using that to determine reaction orders and rate constants. But rather than in experiment 13, where we actually use the method of initial rates to determine that information, we're going to be taking experimental data and graphing it to determine reaction order, and then using a lot of the same methods that we've already used to determine rate constants. So this chemical equation here is what we have data for. And with any chemical equation, we can write a generic rate law by saying rate equals rate constant times the concentration of each reactant raised to powers that are reaction orders. And again, we cannot use a chemical equation to directly provide those reaction orders. We need to use experimental data. So again, to contrast what you did in experiment 13, we did the method of initial rates as a mechanism for determining reaction orders. In this lab, we're going to provide you data where you will be able to use Microsoft Excel and an analysis of that data in a different way than we use the method of initial rates to determine reaction order. So two sets of experimental data, and like we have with the method of initial rates, you're going to be holding one set of concentrations constant while you manipulate the others and you look at how the reaction rate changes. So looking at our generic rate law here, if we were to hold oxygen concentration constant, so what we would have here is essentially two constants in this rate law. So this rate constant obviously is constant, but if we're not changing the oxygen concentration, we can lump that together with this rate constant and create a new rate constant. Let's just call it K prime and rewrite our rate law here. Rate equals rate constant times the concentration of NO to the power x. We're going to use experiment 1 data to determine what the value of x is, what the reaction order is, by determining what this data looks like when we plot it in 3 different ways. We're going to do the same thing then with holding NO constant. So again, holding NO constant allows us to merge these guys together as a new constant. We're going to call that one K double prime. So we can rewrite our rate law now as rate equals our rate constant now is K double prime times the concentration of oxygen raised to the power that is Y. We're going to use data from experiment 2 to help determine the value of Y. All right, so I want to highlight, let me make sure I can see what I am showing you here as I hold something up. So page 5, so there's going to be 2 things that you need to turn in from this experiment. There's this page that says like experimental results. So you're going to turn in your Excel workbook, but I'm going to tell you from whether it's from our Excel workbook or whether it's from this sheet, I'm going to tell you stuff that you need to put down here. So, and I think, at least on the lab that I have, I don't know if the page numbers are the same. I think this is on page 5 where it says experiment 14 results. It says turn in all of the plots and then report the rate parameters below. Is that, do you guys see that page? Lauren, I can see you, so that's the right page? Okay. Where it says, what is the rate expressed in terms of NO? Okay. That is going to be this guy on the left. So you're going to write this thing down where it says rate equals K prime times the NO to the X. That's what you're going to write in that first spot. That's the rate if we expressed it only in terms of NO because we're holding O2 constant. And then the next thing says, what is the rate expressed in terms of O2? So that's this guy. Rate equals K double prime. That's when we have 2 little prime marks there. We call that double prime times the concentration of oxygen to the Y power. So that's what you're going to write in that second line there. Okay? All right, going to move on with this video here. So we still are going to be using experimental data to determine reaction orders, but it's a different way than we learned how to do with experiment 13 and the method of initial rates. All right, so what are you going to do with this? And again, I highly encourage you, make sure to watch Dr. Brown's video. He does a great job of walking through how to analyze this data using Microsoft Excel. My video here is more just on the theory and the background for how this is going to work. So what we're going to do with experiment 1 data is we're basically holding oxygen concentration constant, and then we're looking at how the concentration of NO changes, and we see resultant changes in reaction rate. So what we're going to do is plot 3 different things as a function of time. So time is always going to be on our x-axis, but we're going to have one plot where we look at the concentration of NO directly, and then we're going to have the ln of the concentration of NO, so the natural log of the NO concentration, or inverse NO concentration, 1 over. So you need to create these data sets and then learn how to plot them as scatter plots in Microsoft Excel and see which of these data show you a straight line. When you get data that shows you a straight line, that is going to tell you that that is the reaction order. Do you remember when we have these 3 different flavors of equations that we can use for 0, first, or second order processes, right? So what we can have here is when we plot these or put these equations in these forms, we basically see that they take on the form of a y equals mx plus b, or a straight line. So when we have a certain reaction that fits a straight line, when we've plotted 1 over NO concentration versus time, we can see that that is going to be this flavor of an equation, right? So our x is going to be our time there. Our y variable is some way of analyzing a change in concentration of our species there. And what we're going to see here is that we will just be able to use whichever plot gives us a straight line to tell us reaction order. Okay, we're going to get to some more pieces of it here, but I want to start analyzing our data. So what we've got here, and remember I said that Excel likes to see things where we're plotting, or we have our X data first, and then we're going to have our Y data. Look at this, is holding this guy constant. So we're not going to be plotting here. We're actually going to be plotting time as a function of NO. So we need to plot this 3 different ways. So the first thing that we need to do is actually generate the other 2 columns of data that we need. Because remember, one of these plots, let me come back here to my video, one of these plots is plotting the NO concentration directly. The other one is the natural log of the concentration, and then another one is 1 over the concentration. So what we need to do is we actually need to figure out the ln of the NO concentration. So I'm going to put that kind of column heading in there, and then 1 over my NO concentration. Okay, so give those 2 column headings there, and then we're going to go through how we calculate this. So we've already done the ln function here, so I'm going to say equals capital L, capital N, parentheses, and then I'm going to choose this cell because I want the natural log of that concentration. I'm going to close my parentheses and press return, and that gives me the natural log. And I'm going to drag this down. I'm going to do the same thing here with 1 over. So I'm going to make a formula again. I'm going to say equals, I'm going to say 1 over, and now I have to make sure I come over to this column. Don't go to the column next door. I want it to be over the NO concentration. So I'm going to select that. I'm going to say return, and then I'm going to copy that down. Okay, so I'll give you a minute to kind of populate those 2 columns so we have all of our data. And then we're going to move on and make our 3 plots. I'll give you about 10 seconds here. And after 10 seconds, I'll ask, if you need some more time, I'll ask you to unmute and just say that you're not ready yet.
I have a question real quick.
Yes. Yeah.
For when you gave us the answers on for the Word doc.
Yes. You talking about on page 5?
Yeah. What's the rate expressed in terms of O2? I wrote something down, but I don't necessarily know if I looked at the right thing.
So the rate in terms of O2, rate equals K double prime. So it looks like quotation marks.
Yeah.
Times the concentration of O2 to the Y power.
Okay. Thank you.
Yep. Does anybody need more time on kind of filling out your ln and your 1 over columns here?
Could you repeat the steps for the ln column?
Yep, so for the ln, and again, let me go through, I'm going to delete mine here so I can do it again. Okay, I'm going to say equal, capital L, capital N, means take the natural log of. I'm going to do a parentheses, and I'm going to select the cell right next door because that's the NO concentration, and then I'm going to close my parentheses and hit return. And then I can drag this down to copy that formula. Okay, does anybody else need some more time before we move on to graphing?
And what are the steps for the second one?
So for the second one, let me go ahead and clear this out so I can just show you again. I'm going to say equals 1 over, because I'm just doing what it says to do here. I want 1 over my NO concentration, so I'm making a formula that does that. 1 over, and my NO concentration is right here. So I'm going to select that, and then I'm going to hit return. And I'm going to drag this guy all the way down. Yep. Okay, so now we need to make 3 plots. Just like my picture was showing me over here, I want to make these 3 plots, and I'm going to see which one is linear. And as a, spoiler alert, it's going to be this guy. But let's just confirm that for ourselves. And part of what you need to do to get credit for this lab is turn in your Excel workbook that has all of this. All right, so I'm going to show you a trick here because we don't want to plot O2 concentration. So I can't select this like that. And if I try to go over all the way and select the NO data, well, then I'm including the O2. So I'm going to show you how to do this on a Mac. And Liz, maybe you can speak up and say how to do this on a PC. I'm going to select the time, and then I'm going to hold my, I think it's command. Let me check. Yeah, if I hold my command key down, I can come and select something that kind of hops over a set of data. So when you get to something, and just watch for a second, and then I'll have Liz say how to do this on a PC if you can't figure it out. We want to, again, insert, and we want to do a scatter plot. So do a scatter plot, and here's what we have for 1 over NO. Okay? Or I'm sorry, this is NO versus time. So this is NO versus time. Okay? Does this look like a straight line? Does not. Okay? So what we need to do is we're going to put and make 3 plots here. So I'm going to make mine just a little bit smaller so I can fit all 3 on my screen. Now I'm going to select my time again. I'm going to hold my command key and come over to my LN data. I'm going to insert a scatter plot. Nope, still not a straight line. Okay, maybe third time's a charm here. My time data, command key, this guy. And I'm going to insert scatter plot. That looks like a pretty okay straight line. All right, so Liz, walk us through how do you select multiple non-adjacent sets of data in PC?
Okay, I'm trying to figure it out. It's taking me a minute.
Hold control when you go to select the second one.
So it's control on a PC. Thank you. I think that was Dylan.
Yep, no
Yeah,
problem.
but I'm still trying to I'm trying to do it, and it's like selecting things. I'm sorry, I'm flustered. I dropped all my raspberries on the floor.
Oh, no, don't worry about it. I was just calling on you because I knew you were given PC advice before. So
I'm trying. I can't highlight like. Sorry, I can't highlight the NOs. It's not. It won't highlight for me. Wait.
So are you
Yeah.
at least getting the time one?
Yeah, I can get the time one. I can highlight the time.
So highlight the time,
Okay.
then hold down control and
Okay.
highlight NF.
Make sure you're holding it down before you start the highlighting process. Otherwise, it could just be a matter of timing.
But it just like highlights it clear, like it doesn't.
Yeah.
Oh, okay, it did it. It did it. Okay. So now I insert a graph.
So we want to make sure it's a scatter plot. Okay.
Yeah.
And then, so if you've got this done and you're feeling especially ambitious, please go ahead and start working on the second set of experimental data. We got to do the exact same thing with this second one. We got to do the natural log of, and now this time we're going to do the natural log of the O2 concentration. So feel free to start doing this next set of data. Exact same things that we just did with our other data. So I'm going to put this in here so you can make sure to check your numbers and see that you get the correct numbers here. And then that your plots look the same. All right, so I'm going to ask you guys to do the same thing. Use the chat. Seeing there's something in the chat here. Megan, do you still need me to repeat the steps for the LN column, or maybe you unmuted and asked that?
No, I'm good. It was for the last set.
Got it. So I'm going to ask you guys, when you have an Excel spreadsheet that looks like mine does with 2 sets of experimental data and then 6 graphs, just say done in the chat. And again, I'm going to look for, I guess I'll look for 19 now if Ashton's still working with Anna.
Can you go over how to do the 1 over O2 again?
Yep. So let me clear this so that I can show you. So I'm going to put an equal sign, and then all I do, like the column heading says, I want to take 1 divided by whatever my O2 concentration is. So I'm going to say 1 divided by, and then I'm going to come over here to where my O2 concentration is, select that cell, and press return. And then I'm going to drag this guy down.
Thank you.
You're welcome. Thanks, Anna. All right, I think I'm at 16, including Ashton. All right, 17. No rush. I just want to make sure we don't move on until we've got everybody 18. Who am I missing? If you're still working, just unmute and let me know who's still working.
I messed up my LN on the second one, so I'll be in
Okay.
1 second.
Okay. All right. So that might be it because I just saw Lauren come in. All right. So Dylan, since I think you know what's what's going on, I'm just going to move on here and highlight. There's 2 things that we're going to get from this. The first is we need to look at the shape of the curves and pick out the one that shows us a straight line, and that will tell us the order. This is one of those important strategies for figuring out reaction order, is we might be able to look at the shape of the line and tell reaction order. So whatever gives us a straight line will tell us that. So if we got a straight line with just the straight up concentration, that would be 0 order. If we get a straight line with the natural log of the concentration, that's first order. If it's 1 over the concentration that gives us a straight line, that's second order. So on your page number 5, there's a spot to write what your X and Y values are. So X is going to be the reaction order with respect to NO. Does everybody make sense that that's a 2 because this data tells me it's second order? I'm going to write a 1 for my Y equals value because I know that my reaction is first order with respect to O2. Okay? The last piece of information we need to get from our Excel work here before we're kind of done with our Excel workbook is any place that there was a straight line, I want to know what the slope of that line is. So this is stuff that we've already done. Go ahead and again, you want to select this data. It's, I think, control. It's control for Mac people and PC people, if you remember what it was, or I feel like it was, I don't remember what it was for PC people, but control, I'm going to add a trend line. So just like we did before, I want to add a trend line. I wanted to display my equation and our squared value. Okay. And I need to move stuff out of the way here so I can actually see it. And there's my stuff there. And I don't need to do anything with like scientific notation or anything because it's a number that's large enough. Okay. This number is going to go in where it says K prime. That is the slope of my line. So above where you said X equals 2, you're going to write 5.9681 because that should be what your slope is. Okay. Same thing for this guy down here. I'm going to fit this to a trend line. Now this time my slope is equal to minus my rate constant, or my constant. So I'm just going to write in what the negative of my slope is. So it's actually going to be positive 3.5304. Okay. Now the last thing I want to make sure that you guys get in here, because units are important for this second order process. So when we're talking about what K prime is, so that's above where you have X equals 2, I want you to write M to the minus 1, then S to the minus 1, okay? Because that is the units of our second order kind of merged constant there. Okay, for this guy, I want you to write the units S minus 1. There's no M part to it. It's just S minus 1. Okay.
Can you repeat that for the units?
Yep. So the units for the top one, which is going to be above where X equals 2. So it's 5.9681, M to the minus 1, S to the minus 1. It's a capital M for molarity. And then for the second one, it's just S to the minus 1, which if you haven't heard this terminology before, that's what we call reciprocal seconds. Or I could say the first one is reciprocal molar reciprocal seconds. That's what it means when we say that. All right, so this is actually all that we need to do with our Excel workbook here. So if you're done, make sure to go ahead and save it. Right? You want to make sure to enter in your name and then save that workbook. You're going to need to submit that Excel workbook as part of the work that you submit for this lab. Is there anyone, and there might very well be, anyone need some more time working on this Excel workbook before we kind of go through to do this last part here? Speak now or forever hold your peace. All right, I'm going to go on. I'm going to go back to my video to kind of walk through some of the calculations. So we're going to go through, if we're looking at kind of your worksheet here where it says show calculations for K, I'm going to be going through that. So I'll let the video play and then I'll also pause it and highlight that these are the calculations you need to write down. So the fact that the shape of a plot of 1 over gives us a straight line tells us that we are second order with respect to NO. So that tells us that x is going to be equal to a 2 there. And also one other piece of information that's important to get from this plot is the slope of the plot will give us the rate constant, that merged together rate constant, which we called k prime here. So after you've plotted this data and looked at 3 different plots and determined which one gives you the straight line, that will tell you the reaction order, and then the slope is an important piece of information that tells us that merged together rate constant, k prime. Okay, so I'm going to go a little bit more quickly now because the second half of this paper here walks through how we do that for the second set of experimental data. So the second set of experimental data is now where we're holding NO constant. So that's going to be looking at changes in oxygen concentration as a function of time. And again, we're asking the question, which one of these is linear? When we see here, if we plot the natural log of the oxygen concentration as a function of time, and that's what gives a straight line, that tells us that this reaction is first order, right? So first order with respect to O2. So again, we can put this in, and now we know that y is going to be equal to 1 because it is first order. And other piece of information that's going to be important to get from this line is the slope, because that is going to be this merged together rate.
So let me just highlight here. Do you see, if I look at my equations over here, do you see how there's a negative here? I didn't write this negative right here, but my slope actually gives me minus k, which is why this slope has a negative value. So the minus of that minus is why this ends up being positive. So I just wanted to make sure to point out that that's how we get positive numbers for both of these.
Rate constant, which we called k double prime. All right, so after you've done that graphing data on Excel, 2 pieces of information we're going to need to have, k prime and k double prime. We get the reaction orders from picking which plot was a linear plot, and then we need to know those rate constants. We need to know the slopes of those 2 linear plots. All right, so what do we do with all of this now? Okay. Oh, this is just a figure or a picture here that kind of shows all of that together. So if you wanted to pause for a second and kind of take a look at any of this, this has all of this information together. All right, so now what do we do with all of this information? So to summarize, from experiment 1, we now know that the reaction is second order with respect to NO because a plot of 1 over NO versus time gave us a linear plot. The slope from that plot is going to give us K prime. Okay, go to experiment 2 data. Now we plot ln of the oxygen concentration, and that's what's going to give us a linear plot. So that told us it was first order with respect to O2. So that rate law looks like this. Rate equals rate constant times O2 to the first power, first order. Again, the slope is going to give us that K double prime number. All right, so what do we do with these? Because at the end of the day, we really want the rate constant for our full experiment, our full rate law, right? Well, I'm going to talk about this as being our decombining of constants. Remember that we created these K primes and K double primes by merging the K with a concentration that we were keeping constant. So now we're going to just deconvolute that. We're going to break it apart. So recalling here, remember when we made this new constant K prime, right? It's because we merged these guys together. Well, now that we know what K prime is, and we know what we set K prime equal to, and we know what that concentration was, and now we know what that Y is, all of a sudden the only variable that's left is K. That was a lot there, so let me go through it again if it was unclear. When we made this new constant K prime, we made it by merging together 2 things that we knew were constant. The K that we're interested in for our overall rate law, and then since we were holding the concentration of oxygen constant, we sort of merged it together. Well, now we know lots of pieces of information. Even though we held this constant, so we sort of merged it together, we know what that number is. And we used the plot of our straight line to tell us what Y was. We learned that it was second order here. And we know what the slope of that linear line was. That was our K prime. So now that we have all of these pieces of information, the only thing that's unknown here is our K value. So we sort of break this back apart to get our value of K.
All right, So I'm going to pause it here for a second. Where on your sheet it says show calculations for K, this is essentially what you should write. Okay? Show calculations for K. I'm going to give you a minute to write that, and then I want you to leave half of the space on sort of the right side here, because there's a second sort of calculation for K, but now we're going to be using K prime. So I'll give you a couple minutes to kind of write this stuff down. We're getting a value for K here. Okay, so write that value down. I'll give you a minute to ask questions too if you have any questions on this. That is not an attractive freeze frame. So I'm going to unpause it here, and it's going to walk through the same thing now, but using our K double prime. All right, a little bit more quickly, I'm just going to go same thing on the other side, right? We merged things together here to create our new constant K double prime. So these things got merged together. We said that they were equal to this. So now that we know what our rate constant K double prime is from the slope of our plot, we know what x is equal to 1 because of what we plotted to get a straight line, and we know what we held that NO concentration to when we kept it constant. We can solve now for K. So now we have rate constants that we got from each of these sets of experimental data. Okay, so I'll give you a second. These are the two things that go in as calculations for K. And then when it says, what is the value for K using K prime? What's the value for K using K double prime? That's these numbers that are down all the way at the bottom, okay? Make sure that you have the right units in here as well.
For the answer for just regular K on the left side,
Yes,
is that 7.19 times 10 to the third?
I think so. That's what
Okay.
that's what I have here. Yep. All right, hopefully everybody's close to being finished kind of writing this information in. So we're about 2/3 of the way down our page here with the stuff that we have to put in. And now what we're going to do is sort of like the same kind of thing we did with experiment 13. We had different experimental data that we could use to give us a rate constant. But to have the best sort of example of what that rate constant is, we're going to average our data together. So that's kind of what this last little bit is here. Last thing to do is to say, well, there's always potentially some experimental error, so let's average these guys together. So the last piece is saying, you know what, let's average these guys together, and then when we put it all back together, now we can get our full rate law that has the rate constant as well as the reaction orders for both NO and O2. I know that was a lot, but hopefully it all made sense. All right, so that was the end of that video. And again, for anybody who needs to or wants to sort of rewatch that video, it certainly is available on Blackboard, sort of under our main Blackboard space. But I think there's only one post-lab question, which I think both myself and Dr. Brown are well into equilibrium right now, that you should be able to write a KC for a reaction. And I believe that's the only post-lab question you have for lab 14. So as long as you've filled in this experimental sheet here and you've done your Excel workbook, you should be done then with lab 14, which means the only thing that is really due next week is going to be the pre-lab for lab 15. This is another lab that's going to be done in your lab notebook. So make sure to kind of look and see. We need to have a little bit of a procedure. Let me see if I have my lab notebook in here. I don't know if it's in this office. Yep, here it is. So we are doing lab 15. Here for calculating an equilibrium constant. So like you had with your last lab, writing a pre-lab, your pre-lab is basically taking a stab at writing the procedure. Okay, so I haven't yet posted experiment 15. I will do that shortly. But again, your pre-lab is in your lab notebook to write up kind of a first stab at what you think steps for a procedure will be. So I will stick around here for a little bit if people still have questions on anything, if you still are working through your Excel workbook. But we are all set if you've finished all of that work.
You said we had to do KC still. Where's that on this?
Oh, you know what? Let me look, because it's possible, because Dr. Brown I know made some edits to, let me stop sharing here. I think Dr. Brown made some edits to the Lab 14 document. So let me just look and see. It's possible that it might not be there, because I know he deleted a couple of questions. Yep, it's gone. So it's not even there. So there isn't there. And I see some people were commenting in the chat that they didn't see things. So yeah. There's nothing else then to think about doing for this lab.
Thank you.
You're welcome.
Thank you.
All right, we'll see you guys.
I just have a question. I also
Yes.
have a MacBook, but how do I have both of the Excel workbooks that we did. How do I get it to save to my computer so that I can upload it? Because it says saved, but I don't, like, there hasn't been a thing to like save as or export or anything.
Well, Gabrielle, if you want, let's see. Why don't you try sharing your screen if you don't mind?
Okay.
And then I'll see if I can maybe see something in there.
I think it's this.
All right.
So I have the file, and there's like save a copy or save as template, but
so what if you do save a copy? What does that allow you to do?
oh, okay. So
Yeah, so that I think under options, so if you click on options, that might allow you to choose
oh.
Nope, that's not it. What if you click on online locations?
Okay, that just moved it to my Mac then.
Okay, all right. So hopefully maybe that allows you to figure it out.
Okay, file already exists. Do I replace it or?
Maybe it's there. So
maybe if I add like, you know, a little, it'll like, okay. Autosave your changes as you make them. Oh, I already have autosave on, so that's okay. Okay.
Yeah, it looks like it's definitely saved someplace, but the question might just be a little bit of sleuthing to figure out where it is.
All right. Thank you.
All right. Have a good day. We'll see ya.
Yep.
Bye.
Bye.